The next thing we want to do is be able to take a table of values or a story that give us a quadratic model and go from that table of values or story to an actual equation for our quadratic function. And we had a number of ways of doing that for a linear model. We had ways of doing it by hand. We also had a way of doing it with technology. There's good news and bad news about quadratic functions, and it's the same news. And that is, there is no nice way to write down a quadratic equation from a table of values by hand. So, rather than spend a bunch of time futzing around learning not nice ways to come up with the quadratic function from a table of values, we're just going to use technology to do it. So let's see how that works out. Here we have a table of values illustrating the law of supply and demand. The law of supply and demand says that as an item's price increases, the number of items sold will decrease because people are going to buy less of something if it costs 20 bucks than if it costs $1. So a company's revenue, if they charge more for things, they make more money, except they don't sell as many things. So that also slows down how fast the amount they make goes up. The company's revenue is not a linear function of the price they charge. It turns out that a quadratic model is a very good fit for many items. So here we have a table showing the price the company charges for an item versus their revenue in thousands of dollars. And we're going to first examine the pattern in these values. So going from 95 to 180, well, we'll work out 180 minus 95 is 85. So here we add 85 to the revenue. 255 minus 180 is 75. So here we're adding 75 to the revenue. 320 minus 255 is 65. So here we're adding 65 to the revenue. 375 minus 320 is 55. So here we're adding 55 to the revenue. So when we add $1 to the price, we don't add the same amount to the revenue every time. But notice the pattern in these numbers. So 85 minus 10 is 75. 75 minus 10 is 65. 65 minus 10 is 55. And so on the table we see that the change in y is not constant, but the change in y is constant. We know we expect a quadratic model. Now we're going to use the calculator to figure out what that equation is. How do we do that? The first thing we need to do is enter our values in lists, just like when we were going to use linear regression. So we'll say stat, edit, clear out anything you currently have in the lists, and then we'll enter our x values in one list, 1, 2, 3, 4, 5, our y values in another list. Going to give that a quick proofread. Looks good. And now we want to generate a quadratic function. So I'm going to hit stat and go over to the calc menu. We used linreg, linear regression, to get a linear equation. To get a quadratic equation, we're going to use quadreg. So quadreg stands for quadratic regression. So I'm going to choose that option. My x values are in L1. My y values are in L2. I'm going to store my equation for later use. So I'm going to say vars, right arrow wants to get y vars, function y1. And now I'm going to calculate. In the screenshot, we see we have the form of the equation, y equals ax squared plus bx plus c. Our a is negative 5, so we have negative 5x squared. Our b is 100, so we have plus 100x. And then our c is 0. I'm going to write down plus 0 at this point, so I know I didn't just forget about c. But then when I go on to work with this equation, well, adding 0 doesn't do anything, so I don't need to do anything with that. If I want to know what revenue they'll make if they price the item at $375, well, y of 375 is negative 5 times 375 squared plus 100 times 375. And I'm not going to bother with plus 0. On the calculator, I'll say negative 5 times 375 squared plus 100 times 375. And I get this decimal. We'll think about that a little bit more in a second. Since we stored the equation, we can also use that the calculator knows function notation. We start our equation in y1, so we can take y1 of 375. So vars, y vars, function y1, parentheses 375. And here we get exactly the same answer using our stored equation. Because we didn't have to do any rounding when we wrote down our equation. We can just give this exact value, 304.6875 thousand. That feels a little bit weird since, all the numbers in our table were whole numbers. Probably in practice, I would round this to something like 304.7 thousand to give my answer. How much revenue will they make if they charge $375? Well, almost 305,000. So now we can, using the calculator, create a quadratic equation to describe a situation for which we have a data table. And we can easily use it to ask the kind of questions where we're given a value of x and asked to find a value of y. Because this is not a linear equation, the kind of question where we're given a value of y and asked to find a value of x is a little bit more challenging. And we also have a new kind of question that we can ask about a quadratic function that we could not ask for linear functions. In particular, we can ask questions related to the vertex. So those two things are the next two things we're going to see.